So here we have pointers in memory. So we're going to learn today about primitive and complex types. We're going to learn about assigning variables. We're also going to learn about checking if things are equal. Like, what does that mean? Like, what is one value equal to another value? Asserting that, what does that actually mean? And we're going to work with some arrays. We're going to work with slice. We're going to have a grand old time. So primitive values are, as the name might imply, they're pretty straightforward. They don't hold a lot of data. And so we say that they're primitive because, it's not a bad thing. That's actually a good thing because they're simple to work with. You have a string, number, Boolean, undefined, null. Those are all primitives. We kind of know what they're all about. Like, a string is a string. It just holds that value. So the name, if we said let name equals Harry, that's all you get there. But once you start getting to objects, they can hold a lot of different things, and they are called complex values. And a lot of, once you look at some object, like let's say there's an object called, game, like tic-tac-toe game, right? It's complicated. Like, there's a lot of properties on it. You could click dot play, you could do dot clear, you could do dot start over, dot reset, like all these different options, and then you have to manage all that in your head. And so that's complex. Arrays can be complex too. There's a lot of elements in there, and those elements could themselves be objects. So there's a lot of nesting that goes on too. Like, you could have an object that has another object inside of it, and then you could have an array that has another array inside of it. You could have a function that has another function inside of it. So you can't really do that with strings, numbers, booleans. It's like what you see is what you get. You don't have to unpack different layers, and that's what makes working with primitives pretty straightforward and intuitive. So as we see here, it's pretty straightforward. When we add things, it will log the concatenated strings. New York, I believe. Yeah. British city would be, so sorry. So when we log this, are there any guesses what this would log to the console? British city would be York, yes. And then American city would be New York. This may seem simple, but it actually tells us a lot about primitive values, in that we could imagine in some world where, once you change, because you're setting American city to equal British city, we could somehow imagine, oh, they're equal. Are they the same thing now? So then when you add to American city, it also by transitive effect affects British city. And it doesn't do that. Anderson got the correct answer. It maintains its own identity. I don't know why it didn't. Yeah. If you look up here, British city is still York, and American city is still New York. They maintain their own identity, even though we set them equal to each other, right? Which is kind of weird, because it's like we could imagine that they now are linked in some way through some channel, and so whatever changes happen to me happened to the other one. But it's not really like that. It's more like twins or something, where when they're being made, they're very similar to each other, but once they're born, they're their own identity, and whatever one twin does, it doesn't just happen to another twin in terms of like physical things that happen to them. So you could think of it like that for primitive values. They maintain their own identity. Even if you set them equal, a change to one of them afterwards won't affect the other one. And this isn't that these aren't just things that we normally think about, but these are things that could cause bugs and unexpected behaviors down the line when we don't think at this level. But again, primitive values, when we set them equal to each other, we're essentially cloning, but we're not. So we're cloning them so that they look exactly the same for that time that the cloning happened. And then after that cloning, everything is their own identity. They're their own person. They're their own variable. Whatever you do to one of them, it won't affect the other one. And this is the same for strings and numbers and booleans and all those. But here comes the array. And now, what will this log to the output, to the terminal? Any guesses?
Will be York.
Close. Note that this is line 5.
Would it be York new?
York new. I think you're close. The important thing here is like, would these be different or would they be the same? Like line 7 and line 8, would they be the same or would they be different? And same. Yep. That is different than what we saw before, right? Because before we saw that they maintained their own identity. Even though line 3 happened and we set American city to equal British city, we were essentially just cloning that variable. And then after the cloning happened, each has their own identity. They live their own lives. That's different from this. From arrays, when you change one of them, after you set them equal to one another, you're essentially saying they're the same thing. Like, it's like someone's nickname, right? Like, let's say you had a nickname, but it's still you. So like, whatever happens to your nickname is gonna still happen to you because it's still you. So you could think of British city as, the name. American city is the nickname now because like you're calling this that, but they're pointing at the same thing in memory. And so when we look at the console, I don't know why this is. Yeah, they're gonna be the same, and now they're intertwined. And this is a cause of some unexpected behaviors. You could imagine that, I'm just changing American city. Like, why the hell is British city changing too? That's pretty unexpected, and you kind of don't want that in some ways because, when I'm reading this code, just like as if it's a book, let British city equals York. And I never touch British city directly after that. And then it just changes. Like, that's unexpected. Like, I want this to be York, and because I haven't done British city.push or British city.pop or any of those methods on that array, like I want this to be York. I'm expecting this to be York, and American city changed, but like, let's say I just kind of missed this line because I'm just reading through the code, then like, like I have some unexpected behaviors now, and that link is dangerous sometimes. So you could think complex is nickname, primitive is cloning. So why do they behave differently? Well, we can find out a more technical answer to that, but the important thing is that you know that. So when you assign a primitive value, the variable stores a copy. So like, again, the whole thing with cloning, you just get a copy of it. You don't get the exact place in memory where that exists on your computer. You're getting like just a copied over value. And it's really easy to copy the number 20, right? Because it's just a small piece of data. Like, it's just 20 and you just make a quick copy. It's kind of like copying one piece of paper versus copying an entire book. Like a book can be an object, like it has so much stuff in it. Copying that is not trivial, and so they're not just gonna copy it for you for free out of the box if you just set an assignment, because you're making the computer do a lot of work if you want to copy a complex value. So primitive values, computers like, that's easy. It's like copying one sheet of paper in the copy machine and do it in 2 seconds. So when you do first equals 20, that value exists in memory. And then when you say first equals 30, stores a new value. When you say second equals 30, 30 is its own special value. And this is, everything gets its own copy for primitive values. And part of it kind of makes sense because it's really not that much data, pretty trivial to make copies of things. So when we do second plus plus, now it has a new value of 31. And then first and second should be 30 and 31.
I have a question.
Yeah.
Is there a purpose of having let first equal 20 if you're just reassigning it to 30? Why not? If someone were to go through and edit the code, would it just be better for them to just get rid of the let first equal 20 and then just let first equal 30? Is there a purpose behind leaving the let first equals 20 if we're reassigning the value?
Probably, like this code right here, you did a good job of pointing out it's probably useless. You're right. So we should just go let first equals 30. But something like this might happen if we said, like, for example, like you might see something like let feeling equals happy, right? And then you might like say if day equals cloudy, then like feeling equals sad. So you might see some stuff like this where it actually has a purpose, but you're right, like this is just for a point of example. But even this, in this case, feeling is happy and then feeling is sad. These are totally two different places these are two totally different pieces of data. But yeah, this is just contrived. Like you probably wouldn't do this because it doesn't really make sense at this point. Good question. So yeah, we just reassign it. It stores a new value, brand new value, and it's different than this 30. It's just because they're both 30. Doesn't mean that like it lives in the same place. It's a copy. So yeah, first, let me try to see what this graphic is doing. So first is 20, and then when you reassign it, it reassigns to a brand new value of 30, and second points to its own value of 30, and then when you boost it, it goes to 31. So yeah, they're all just unique entities. So let's do this tricky thing where, yeah. So now we're assigning we're assigning second to first. And so, I mean, this kind of shows you the answer already, but yeah, it doesn't have any effect on first because for primitive values, and this is only for primitive values like strings and numbers and Booleans, when you set one value to equal another one, you're essentially cloning it. They still have their own identity though. And even though they're the same value, when you update one of them, it doesn't affect the second one. So first is still 20, right? And then second is also just, it's a copy of 20. It's not the same, it doesn't point to the same thing. It points at its own thing, and they do happen to have the same value, but they're in different places in memory. So they just happen to have the same value, but they're in different places in memory, which means that when you change one of them, the other one doesn't get affected. So yeah, it goes to 21 because we incremented it, but first still stays 20, even though we set them equal to each other. So it may one may assume that now they're just intertwined. They're actually not intertwined. The computer just makes a copy, and copying is cheap because it's a cheap value. It's just 20. It doesn't contain nearly as much information as like the problem that I went over with the fish taco thing, like the cat taco. That was like a lot of stuff in there, and the computer is not going to make a copy of that automatically because copying things takes a lot of time. You got to go to each value and copy things. So when you assign a complex value to a variable, the variable does not store a copy of the value. It stores a reference in memory. So the reference is like a name. And when you call the name, it actually brings you the person, right? So it just stores a reference. It just stores the name that points at a specific place in memory. So first stores a reference to 1020. And when we push to this, it still stores the same reference. And so we actually updated the same array, but we just added an element to it. So yeah, this is kind of like what they mean by reference. It's basically a memory address, and it points to the actual value. So there's a little intermediary here. And yeah, when we mutate them, it updates that same reference. So it's not that different from the primitive at this point because it is kind of different, but we won't notice it until we start setting things equal to each other. That's when things start getting confusing. But for this case, it is kind of different because this value stayed the same, but we just added a new element to that value. For primitive, the value itself changes. So it goes from 20 to 21 when we increment it. And that's a totally different value, right? Whereas here, the value stayed, the object, the array stays the same. It just, we're adding a new element to it. It doesn't really matter that much. It's not that unexpected until we start getting into setting things equal to each other though, which we'll get here. So what do people think will happen when I log first?
Wouldn't it just remain 10 and 20?
Yep. That's because you're creating that's a great answer. You're creating a new reference to a new array. So when you're creating your own array, even though the values are the same inside of them, like they both have 10 and 20, they're different because we created it, we created a brand new one. So they each have their own identity, so they're not linked together. They each have their different memory addresses, and it's like twins that live in different places. They look similar, and when you give $10 to one of them, the other one still doesn't have that $10. You only gave it to one of them, and so one of them is $10 richer, not both of them. So they're not interconnected because we defined a whole new array, and this is a whole new place in memory, even though the values are the same. Now we're getting to the tricky things. Any takers for this? What this would output?
Would it be 10, 20, 30?
Yes, it would be because they're connected now. Because when we set them equal, we just do this. This is where it's different from primitives, because for primitives we have, name is David, and then we could say let me, right? And then if we change me to be Martin, then what would twin be? What would my twin's name be?
Martin.
Yeah, or no, it wouldn't. It'd still be David, because these are primitives. And so what's actually happening is in this line 2, it makes a copy of David, but it's not the same David that is with me. So here, my twin would still be David. My twin would still be David. But then when I reassign this, I'm only reassigning me. My twin still has, my twin is still David. But only because this is primitive. This is a string, and it's really cheap for the computer to make a copy of this. So it'll make a copy, and whatever, when you are in a copy machine and you're making a copy of 2 packets, right? Like, now you can mark up on one of them and the other one still stays the same, right? Because you've made a copy in the copy machine. And making a copy of primitives is really easy for the computer to do because it's not a lot of data. But once I do let my clothes is going to be something like t-shirt and pants, right? And then if I do let my twins clothes, or I won't use twin, but like it'll just basically be like a nickname. So let's say like I had a nickname and then I had like Deco or something equals David clothes. And then I said David clothes dot push. Or let's just, it doesn't really matter which one, but all right, sandals console.log deco close. Any guesses what this will log when I do deco close?
T-shirt, pants, sandals.
Yeah. And that's because when we do complex values, right? When they're objects or when they're arrays, it's no longer cheap to copy. I mean, like for this case, like it would still be cheap because it's an array of 2 elements, so the computer could easily make a copy of that. But it theoretically could be a billion lists, right? And so the computer is not gonna like automatically give you the copy functionality out of the box. You're gonna have to explicitly tell it to, and I'll go on to show how we can make copies of complex pieces of data in this lecture a little later on. But out of the box, it's not gonna make a copy. It's gonna point to the same thing. So it's like a nickname, like Deco clothes equals David's clothes. They're the same person, just different names for the same thing. So it's not even like creating a clone. It's literally the same thing. When so that's kind of like what this slide is showing right here. You're affecting both of them because they both point at the same thing. When you assign one to be the other, they both point to the same value. It's just a different name, or well, same address actually, but the variable is a different name. So you could think of the variable as like the nickname, and the reference is like your actual identity. Like you can't change that. So this is how we make a copy. If your question was, all right, so what if I have a really long array and I wanted to make a copy of that and like do stuff to it separately, which is a really common use case, because let's say someone created an array and you wanted to use those values, but you didn't want to like mess it up for that person by like changing. So like, for example, someone has a study packet, right, of notes, and you really want those notes because like it's going to help you study for the test, but you don't want to take their notes directly and then start writing on over them because you're going to mess it up for that person. So you'd want to make a copy, and then you could do whatever you want to it, mess with it as much as you want, and then the original copy won't be affected. And so this is how you make copies in JavaScript, is you do .slice with no arguments, and then it just gives you a brand new copy. You could imagine that this is somewhat expensive because .slice under the hood, it'll go through every single element in that array, and then it'll push it into a new array. So it looks really easy, but it still costs the computer like runtime to handle this. Any guesses what this would log?
It'll be 1020.
Yep, because you cloned and now they're different. Although, initially the elements are the same, they're different addresses. They live in different addresses. So when you change one, other one's fine. So let's think about like some real world cases where you're like passing things into functions, and this is where things get a little tricky. And this is where I like to show you guys a little trick. But first, the little trivia is like what this would log to the console. If there's any guesses? It's not that straightforward because there's a lot of things happening here actually.
Would it be my num or adds 20?
What? Can you say that one more time? Sorry.
I have a vacuum going in the background. Would it be my num adds 20? Or would it be adds 20?
Adds 20 is the function.
Oh my God, I didn't see that 10. I'm so sorry.
No, it's all good. So my num is 10, and then we pass my num into the function. We add 20 to it. We return that num. So first question is, what would return num be? Return num would be 30, right? Because we just 10. We're not caring about values and what their identities are and all that. We're just like, yeah, we're passing in 10 to a function called adds 20, and that 10, it'll be 10 plus equals 20, so that's 30, and then it'll just return that. So it'll be return num will be 30, but what would my num be?
10.
Yes. There's a lot of guesses here. Sorry, I miss. So return num, so everyone's right because return num is 30, but my num still stays 10 because it's a primitive value, and again, primitive values, we always make copies of things because it's so cheap to make copies. So my num stays 10. Return num is 30 because that's the value of this. So let's see what actually is happening here, because this is not simple by any means. Let's see if I can copy this. Nice. So what's happening here is basically we have my num is 10, right? And then here we this parameter, essentially we're saying let, and this isn't actually, we're not actually typing this out, but this is what the computer is doing, is it's essentially saying let num equals num. Like it's setting a new variable within this function, and then it's setting it to be this. And what is num? Num is, when we pass my num to it, we're essentially saying let num equals my num, because we're passing my num in, and my num replaces num as the actual passed in parameter. And under the hood, like what the computer is actually doing is it's creating a new variable within this function called num. Even though we're never doing let num, we're never doing that explicitly. It's implicit. It's happening under the hood. It's saying let num equals my num. This doesn't really, I mean, we're not typing this out, but it happens. And then so when we say let num equals my num, num is 20 at this. I mean, num is 10, right? Because my num is 10. But it made a copy of the 10 because it's a primitive. So even though we set it equal, it makes a copy, so it doesn't affect the original, which is like awesome. Because if it did affect the original, then that's confusing, because I never touched my num directly, right? I passed it in to this function, but I never touched it. So like, why should it change? Why should this value have changed? It would be confusing if it did, but because it doesn't, it's nice, because we have all these functions. We don't even need to look at these functions. Like, we know that this is always going to be 10, unless we explicitly say like my num like equals 20 or something, right? Then then this no longer holds true. But if we're not explicitly doing anything to my num, then it shouldn't change. And it doesn't, because even though line 4 sets a new variable called num to be my num, this makes a copy. So this is 10, a copy of 10, right? And then you add 20 to that, but that only changes num. It doesn't change my num, because my num, we just made a copy of it for its value, and then we let it stay, have its own identity. Because some people, it's confusing when you see like num, like what is this num, right? Where did it get declared? How come we can use it like this? How come we can use it so like easily within this function? Well, it's not any different. It's actually declaring it. We just don't see it, but it's actually declaring a new variable that we can use within this function. It just, because it's a parameter, we don't have to explicitly declare it, but it gets implicitly declared. And num is interchanged with my num, because this, when we pass in my num parameter, it essentially becomes num. So we're essentially saying num equals my num. Or if this happened to be anything that comes to mind, so like window, like then this would be window. Doesn't matter. It would set it equal to whatever value this is, because this becomes this, because this is just like an expected generic parameter, but this is the actual specific parameter. The specific parameter replaces the generic one. Or the specific parameter, the value of the specific parameter gets copied to the generic parameter variable name if it's a primitive. These are only for strings and numbers and booleans and nulls and undefines and things like that. Now we're all fine and dandy. Are there any questions on primitives? Primitives, they're always going to maintain their own identity. So whenever you think that you're mutating a primitive, unless you're directly like taking that variable name. So like if we did something like this, right? Oh, sorry. If we did something like this, like we didn't pass num, right? And then we just did my num plus equals 20, and then we just returned my num. Then it's gonna change, because, and we'll get into scope and things like, I don't think we've gone over scoping yet, so this might not be that This might not ring a bell, but if we did this, now my num will be 30 because we're actually like reassigning it, and so it's going to change. But because if we, set it equal to some other variable first, so like this is a whole new variable now. Now when we change that new variable, this will stay the same because we essentially cloned it. Now this all to say that this is a lot. I mean, there's definitely been bugs I've encountered and have myself caused due to a lack of understanding of complex values and the side effect behavior that it can cause. So, any guesses what this will log? Yes, Mark is correct in his guess of 1020. And that's confusing, right? Because we're not directly changing this at all. We're passing this in to this function, and now it's a whole new name. Like, it's not even the same name. It's a different name. We aliased it. We gave it a nickname, but unfortunately, we didn't clone it. We forgot one vital step. We gave it an alias. Like, before we gave it an alias and we cloned it. So we're saying like my num, pass it in here, and then this will alias it, give it a new name, but also give it a new value because it's cloning and aliasing. Whereas this, we're missing a crucial step of cloning. So, we could think of this as the same thing. Let's do that exercise one more time. I think initially it may seem kind of weird what I'm doing with this whole redeclaring the let thing, but I think later on it'll start to make sense. So like here we're saying let array equals my array. I mean, we're not explicitly saying that, but we're declaring a new variable. It's a new name now. And then we're setting it equal to my array because essentially this is doing array equals array. It's saying create a new array that's, whatever's passed in here. But as we can see in line 7, what's actually passed in is my array. So we're actually doing this. And as we've seen from beforehand, this is aliasing, but not copying. So the value stays the same. I mean, the value changes with any mutation that you do to it. It now changes the original one too. They're linked. So an easy way to think of it is for complex values like arrays and objects. If you use an equal to sign, they're linked now. They're like bound together. Unless you did, like, how would you not have this happen? Well, you would say array equals array dot slice. Now you made a copy of it. And now they should be different because you made a copy. Moving on. And you can see how that could easily, like, you could easily have a bug where, you start doing stuff to this, and then you haven't mutated my array directly. So when you write your code, you just expect like my array, like let's say you expected, 1 to equal undefined, or you expected my array dot length to be 1. Like you just expected that because, you looked at this, it created an array, it's 10, and then you did some other stuff, but like forget about that because that doesn't even, it's not even the same name. Like it's a different name. It's its own scope. It's its own isolated, contained, encapsulated function. So I'm not going to really pay attention to this. I'm just going to go on with my code and assume that, if my array length equals 1, like earn $1 million or something. But unfortunately, or we'd have to do this like after this. And so like we call this function whatever, but like you kind of expect this to be this, and so you expect to earn $1 million, but it's actually not gonna earn you $1 million because you forgot that it got mutated, and now it's a sad story. So there's a question from Liz. It says, is there a simple way to copy a complex file without using a method like slice? Unfortunately, copying a complex data structure is not trivial whatsoever. And we're going to learn about that a little more later on in the lecture. But it may seem easy, right? Because it's like, it's just copying like a notebook. Like, how hard is it to copy something? Like, copy the name itself implies that it's an easy thing to do. Like, copy someone's test, copy some stack of papers. But what if I said that a notebook could have like infinite number of nested notebooks inside of it, and I told you to copy that? Like, that's hard now, because you know, an array can have another array that can have another array, an object, another object, another object, it could go on for infinity, and you're telling me to copy that? Like, it's not that easy. So I think copying, and if you guys did that question where we compared if two objects were equal, that was like 2 days back. That seemed easy, right? Like, check if these two objects are equal, but it's actually not that easy to do. And so copying comparison of complex data types, not as simple as it seems from the outside, because they could be nested like crazy, and they could also just have so much data in them that like it takes just forever to copy it. So unfortunately, there's not a simple way. You can use slice, and that'll give you a shallow copy, so it'll copy the outer layer, but if there's any nested things inside of it, you're gonna have to handle that yourself. But I mean, slice is basically like this. It's like create a new array, right? Now we made a whole new array, points to a different place in memory. This lives at a different address, and then we just say, you know, original array. It's this for loop. Everything is a for loop. Like, even though things can look like they're getting more complicated, like at the bottom of everything, it's just a simple for loop. And then we just, you know, take the original or new array dot push original array I, right? And then we just like return the new array. That's what slice does. Just makes a copy. But like I said, it only makes a copy of the outermost layer. And we won't get too deep into this, but if this array had another array inside of it, if this original array had other arrays, then it wouldn't by default copy those. It would only copy the outermost layer, and then the innermost layer, you're gonna have to handle that yourself. Equality. This was the tricky one, right? Like, I mean, for objects, like seeing if two objects are equal, you gotta see, are they the same number of keys? Are they the same number? But we're only testing for the and so there's an important caveat here, is that object comparison function, that only compared the values of the keys and the values of the values of the keys and the values of the values. But it didn't actually compare if there was if they lived in the same place. We weren't actually comparing, are these living in the same memory address? Do they have the same address that points at that value? So Ranfi asks a great questions Awesome question. Is there a similar method for objects? And yes, there is. So for objects, you could do A1, B2. Just do let object 2 equals object dot assign. This is the new array. I mean, this is the new object, and then you just copy that over to the new object. Fancy way of doing it is they do the same thing. This is shorter, which is why I use this a ton, actually. This is actually really really common thing that I do all day. It's just like copy objects. But yes, there's two ways. But again, this is only a shallow copy. If there was another object in here, it wouldn't make a copy of this. So what I mean by that is, so let's say we made a copy, right? We think we're good. So, you know, we log. So then when we do object 1 dot d equals 2, object 2 dot d is also going to be 2. They're still linked. So that's 2. Object 2 dot d. Let me see. Console.log object 1, object 2. They are, that's weird, hold on, let's see. We made a copy of it. Dot d equals 2. What the heck was? This is tripping me out right now. Oh, okay. It's c dot d. So look, they both changed. Even though I only changed object 1 dot c dot equals to 2, object 2's d also changed. Even though we made a copy, right? But we only copied the outermost layer. So we only copied A and B, but we didn't copy D, unfortunately. And so now when you change D for one of them, it also changes for the other one, because this object is still the same as this object. It's only the outer one. So like, let's do a better example here where we do like object 1 dot A equals 500. And this is, 1,000, just so that it's a little more clear. Or maybe that's not a good idea because it's too many numbers. So, I don't know why this looks so weird. Let's zoom out. So as we can see here, when we changed A, only one of them changed because, or let's just make it clearer. Right? So, what is this? So object 1 is, different now because I set A to be 5, but the object 2's A is still the same because we made a copy. And so what we do to object 1 does not apply to object 2 anymore because we had cloned it. Unfortunately, D, the object that has D in it, was not cloned because this is a nested object and it doesn't just clone every layer right out of the box. It only clones the top. So when we change object 1 dot c dot d to be 5, even though object 1's d is 1, it changed both of them because it's a second layer, and the second layer behaves exactly the same as it would have if it hadn't been copied, because it hasn't been copied. So but the equality operator, so any guesses what this would log? It's a 50-50 shot.
It looks like it's true.
This would be false.
False.
It's a great guess. Yeah, it's because it's a different place in memory. Equality checks, when we do equals equals equals, it looks at the place in memory. It doesn't care about the values. So this lives in a different home, and this also lives in a different home. It's just like twins that live in this different homes. Like they still live in different places. And so this equality check is asking, do you live in the same place in memory? And so yeah, it's false. They will compare complex values by reference. And reference meaning the address. And the addresses are different. Now, any guesses what this would log?
True.
Yes. Because now you've pointed them at the same place in memory, you've pointed them at the same reference, therefore they are the same, according to JavaScript's equality operator. Now for values, for primitives, they're different. They act differently. So let's say let name1 equals Tifa, and then let name2 equals Tifa. Name1 equals name2. That's going to be true because primitives, when we do comparison, they compare values, the actual value, whereas complex objects compare by reference. So this will be different. This will be false. But now the only way you could get them to be the same reference is like do something like this, and then now it's going to be true because they're the same. They're intertwined. It's a little tricky. So yeah, we showed earlier that slice creates a copy of the array, but it doesn't. But anybody want to guess what this logs when we make a copy? And then we try to see if they're equal or not. Yes, Nathan, great guess. It's false because they are now, you've copied them over to a different place in memory, and so they're not the same, even though they're going to look the same. It is not equal, but they do look the same, which is why looks can be deceiving. So this kind of just says that it's shallow copies. So it would be a beautiful world if we could just easily copy all the insides of it too, but unfortunately we have to handle that ourselves. Thankfully, there's a lot of libraries out there. Like somebody already wrote this code, so you can just use their code to make deep copies. But what this shallow copy means is so anybody want to guess what this would log? We take this, we add 4 to it, and then we log the copied array, that array. What would it look like?
Would it be 4, 2, 3?
Yeah, it would be 2, 3, 4, but you're basically right. It would mutate that same array because we haven't copied the inner array. And then when we do array 1, 1 equals array 2, 1, any guesses what this would log? This would log, it would log, I believe it would log true because they're the same array. They have the same reference. But it was a 50-50 shot. I could have been guessing it. Nobody would know. And so yeah, that's this lecture. It's definitely, I mean, I didn't think it was that important. I was like, pass by value, pass by reference, like who cares? Like let me just like do this thing. Let me just solve this problem, right? But then a couple times I wrote this code and then it was buggy. I was like, what the hell is going on? And I was like passing a complex value into a function, and then I just thought it was fine, but I was mutating it, and then outside of the function it was changing the value, and then this like button stopped working, or like it like broke the website. I was like, should make a copy next time to be on the safe side. And then that whole thing led to like me wanting to figure out what this whole thing was all about. So yeah, that's the lecture.